The main idea in this problem is to substitute some constant k for the value of the expression, and then using your conjugate rules as well as Vieta's formulae to find that value for k, which is then going to be the answer. So now let's look at a similar structured problem which appeared on the 2000 AIME 2, and it was the ninth problem, and it reads, given that z is a complex number such that z plus its reciprocal equals 2 times cosine of 3, find the least integer that is greater than z to the 2000 plus 1 over z to the 2000. All right, so I'll just write down the expression that was given to us in the beginning. And we can notice that if we multiply both sides of the equation by z and move the right-hand term over to the left, we get something that resembles a quadratic. So let's do that. Let's try to get as close as possible to the requested value, which is for z to the 2000 plus 1 over z to the 2000. So let's try to do whatever we can to try to get close, right? So z squared plus 1 equals 2 times cos of 3 times z. All right. Then move that to the left-hand side. You'll get z squared minus 2 cosine 3 times z plus 1 equals 0. Okay. Well, what can we do now? Well, let's employ our previous concepts that we've learned, such as Vieta's formulas, and also what we know about quadratics and their roots. We know that whenever there are complex roots in a quadratic, the roots are going to be conjugates of each other. So we can represent them as z and z conjugate. So let's do that. Let's say the roots of this quadratic, let's say the roots are z and its conjugate. Now we know that using Vieta's formulas, the sum in a quadratic is the sum of the roots in a quadratic, to be specific, is negative b over a, where the standard form of a quadratic is ax squared plus bx with c, obviously. And then the product of roots in a quadratic is c over a. Let me move it over so we can take a look at that. Right? So now we can try to use that to help solve the problem. So we know that for our roots of z and z conjugate, we can say that z plus z conjugate equals negative 2 cosine of 3 over 1, and then negate that again. So that would be 2 cosine of 3. Okay, and then we can do the same thing for the product, and that's just going to be 1, because 1 over 1 is 1, right? Okay. Well, what can we do with this information? Right, we have the sum of the two possible values, and then we have the product, but we don't really know what to do from here. But let's think back to what you can do when you have a complex number z or q. What can you do with that? Well, you can substitute a plus bi in for z, and then try to figure out the components of the complex number to form the entire complex number, right? So let's try to do that for the sum. And let's see what happens, right? So if z is a plus bi, we know that the conjugate of z is a minus bi. And then when we add that, we're going to get 2a. Okay. All right, so if we get 2a as our sum of both complex numbers, that means that 2a must equal 2 cosine of 3. Obviously, it follows that a equals cosine of 3 degrees. So we can write that in for the value of z. So z must then equal cosine of 3 plus bi. So now we have to figure out the value for b. All right. Well, let me get rid of this right here and then move this. And now let's try to figure out what the value of b could be. So let's go back to the second equation that we had written. Z times z conjugate equals 1. Well, what can we do with that information? Well, we know that z times its conjugate is always equal to the square of the magnitude of z. So then we can replace the value for this. So that must mean that the magnitude of z squared is equal to 1. Obviously, that means that the magnitude of z, since it's always a positive number, is equal to 1. Now, this is big because that means that it must always lie on the unit circle. So let's take a look at what we had over here. So if the magnitude of z is 1, then we can say that 1 equals cosine squared of 3 plus b squared, because that's what conjugate is, or magnitude is, right? Should say 1 squared here, but 1 squared is 1, so I didn't bother writing it down. So now what we can do is we can go back and remember that whenever you have cosine squared x plus sine squared x, this is always equal to 1. Now this resembles the equation that we had above, right? If b was sine of 3, the equations are I mean, they're pretty much the same. So let's do that. Let's say b is equal to sine of 3. I scrolled a bit too much, but let me just rewrite it since we know what z actually is. So we can rewrite the whole thing. So let me get rid of all of this stuff. And we'll say that z equals the cosine of 3 plus I sine 3. This is a standard form of a complex number, right? Okay, so now let's go back to what it was asking. The question was asking, what is the least integer that is greater than z to the 2000 plus 1 over z to the 2000? All right. All right, so we can represent this as cis of 3 degrees. Cis basically means cos plus I sine. It's just the shorthand form of writing it. All right, so now we can use De Moivre's theorem, which states that if we are taking some complex number to the nth power. This is the same thing as, let's say this was, let me erase that. Let me try to explain it clearly. If we have cis of n degrees to the x, this is equal to the cis of nx. This is essentially what De Moivre's theorem states. Now, this is excluding magnitude. We know that the magnitude of everything we're dealing with here is 1, so we don't have to deal with magnitude. But if we were dealing with magnitude, then you would have to have the magnitude to the x power multiplied to the right-hand side. All right, so now we'll use this in trying to solve the problem. So obviously this is going to be equal to cis of 3 times 2000. And that is going to give us z to the 2000. This is obviously equal to cis of 6,000. Okay. Now here's what we can do with the requested value. So it's requesting z to the 2000 plus its reciprocal. Well, we can represent z to the 2000 as just simply 1 plus 1 over u. Sorry, u plus 1 over u. Now, if we plug in this value for u, we can get the reciprocal of that value. And the reciprocal of any complex number, let's say that we have a complex number which is at an angle of theta, and we take that complex number and divide it over 1. This will be the resultant. It will be the same amount of degrees below the 0 degree mark. And this is, again, only for magnitudes of 1. So now let's try to simplify cis of 6,000, and then we can apply that concept there. Okay, so cis of 6,000 is the same as cis of 6,000 mod 360, since a circle has 360 degrees, right? So 6,000 mod 360, this is going to be equal to essentially the remainder, and we can just figure that out by dividing. And so we'll be left with 2,400 over 360. We know that 360 times 6 is 2160. And then subtracting that will give us 240 as our remainder. So that means that cis of 6,000 is equal to cis of 240. All right. So now we're left with cis of 240 plus 1 over cis of 240. Well, let's try to figure out what 1 over cis plus 240 is. So if we employ the same tactic as I explained previously, 240 degrees is going to be over here. So that means that we're essentially going to be going 240 degrees in this direction. All right. So we know that 240 minus 360 is 120. So 120 is going to be the resultant. So in essence, the question is asking what is cis of 120 plus cis of 240. Now we know what cis of 120 is because we can look at the unit circle, and that is going to be at this point there. Well, the cosine of 120 is going to be negative 1/2, and then the sine of 120 is square root of 3 over 2. So scroll down. So that's the point that we're going to be at. Now, if we evaluate both of these, obviously cis of 120, as I said, is 1/2, negative 1/2, plus square root of 3 over 2. And then square root of 3 over 2i. And then plus cis of 240 is going to be the conjugate of cis of 120, which means that that's going to be 1/2 minus square root of 3 over 2i. Add these two together, and your answer will be negative 1. So let's look at what the question's asking. Well, the question's asking, find the least integer that is greater than z to the 2000 plus 1 over z to the 2000, and your answer is going to be 0. So this is how you